Hi, this is the mission briefing for the Comm failure mission in Star Racers. To begin with, the subject matter that we're talking about here is sound and light. The situation is that we've got an astronaut stranded outside the International Space Station, and that astronaut has lost communications with the astronauts inside. There is no way for them to talk back and forth. So what we want our students to do is to come up with a method for people inside the space station to communicate with somebody outside the space station. Now, there are two ways that we normally think of in terms of communicating. The most obvious one is through sound. But sound waves are longitudinal compression waves, and they need a medium to be transmitted through. So when I'm talking to you now, I'm transmitting sound waves through the air. If I breathe in a helium balloon, okay, the sound waves are going to come out sounding differently because helium is a different medium for sound waves to travel through. Another medium is water. If we stick our heads underwater, we're going to hear sound differently than if we hear it above land. And that's because sound waves travel differently through different mediums. When there is no medium, when we're talking about a vacuum, like the vacuum of space, there is nothing for a compression wave to move in terms of the vacuum of space, so sound waves cannot propagate. You cannot hear things spoken to you or communicated to you when you're in space, because there's no air for the sound waves to travel in. Light is very different. Light does not need a medium to travel in. Light can travel in a vacuum or with the absence of matter. That's because light is a very different phenomena. It's an electromagnetic wave, so an electric field that oscillates, giving rise to a magnetic field which oscillates as well. Forms of light or forms of electromagnetic radiation include light, include microwaves, include radio waves, infrared, ultraviolet, and so on. These are all different types of light. And like I said, light doesn't need a medium to be transmitted in. That's why light from distant stars can make it to Earth even though there's a vacuum in between. So sound does not travel through vacuum, light does. That means that really what we want our students to do is figure out that light is what they need to use to communicate with our stranded astronaut. So, what can you use? What we want kids to do is we want to be able to come up with a communication scheme. So they could use maybe a laser pointer, for instance, or a flashlight. And how are they going to use this to communicate? Well, a couple simple methods are through a series of on-off flashes, like Morse code, or through different colored light signals. Okay? So we could take a light source like this flashlight, or we could take laser pointers of different colors, or we could put a filter in front of this and use the colors of light to communicate. So we want to teach students about the component colors of light, the way we can use light to communicate, and exactly how they do it is up to them. Now, I'd like to incorporate a mirror into this little exercise. By using a mirror, what we can simulate is communicating around a corner, because light moves in straight lines, right? So there's going to be very little diffraction. So what we could do is you could imagine having kids inside a classroom, maybe kids outside a classroom, maybe a student at the door with a mirror that's relaying the light signals to the people outside the classroom from inside the classroom. There are light source here. The only other thing I was thinking about is you could use filters to change the color of this light. What a filter is doing is this flashlight is giving off white light, which is composed of all the different colors. A filter is only allowing one color through. So we could do that. We could also separate this light into its different colors using a prism, or what I was thinking everybody's going to have access to is a compact disc. If you shine light off the surface of this compact disc at the right angle, you're going to get different colors coming through. So that could be another way, and the effect that's causing that is called diffraction. There are tiny little holes in the surface. Light is coming in, and because of diffraction, depending on the wavelength, it's getting reflected at different angles. Okay? So there's diffraction, there's the prism effect, all these different things that we can start to discuss with this lesson. How your students choose to solve the problem is up to them, and we're looking forward to their solutions.